Hey guys, how you doing? Welcome to the video. Welcome to my garage. In this video, I'm going to show you what I've done to dial in the lower control arm and get it ready to get the parts laser cut. And I'm going to show you how I'm going to figure out my location for the rear shock absorbers. So if you guys remember in the last video, I made the upper link and I made the connection point back here, and I did a little bit of looking at how my geometry is. And when I say that, I mean whether or not the drive shaft was extending or collapsing during its movement. What I've done since then is I had that real rough mock-up of the lower control arm that I was using just to set things up. But now that I'm going to be getting closer to actually dialing in the rear shock absorbers, I have to get a really accurate of the lower control arm. So what I've done is I drew up the lower control arm that I wanted, and I drew that up on Bentech. The files for this, if it's kind of hard for you to tell, but this piece of white paper on here is the actual control arm that I drew up. And what I did is on Bentech, you can print it out on full scale. So I printed it out. It prints it out on multiple pieces of paper, and you tape them together. Also, we're fostering another dog, so this is a new dog, which might be in the videos a little bit more than the other one. They look similar, so this one probably looks like the other dog, but they're different dogs. But either way, so what I did is I designed the lower control arm, and then I printed it out, I taped the pieces together, and then I glued them onto 1/8 inch masonite. I did that for the top piece. You can see this piece here, and this piece here is 1/8 inch masonite or press board, hardboard, whatever you want to call it. And I cut it out right on the line. So these top pieces are extremely accurate. Like, this is the exact size and shape. There's the original. There's the original dog. Right, buddy? So this is a very accurate representation of what the control arm is going to be. And then what I did is the control arm is going to be 1 3/4 inches thick. And so what I have in here is a 2x4, which is basically 1.5 inches thick, a little bit more. And then I've got an 1/8 inch here and an 1/8 inch here. So it's pretty much 1 3/4 inches, which is really accurate what the actual metal control arm is going to be. And then you can see, excuse me, bud, you can see what I did with these 2x4s is I actually coped them out for the heims. And you can't really see that, but I coped it out for the bushings as well. And then I used hose clamps to draw the pieces in there. So you can do that. Alright, so we've got this new foster dog right here. Obviously, typically I don't have dogs crawling all over me. This guy usually, this dog's name is Doug, actually. This one is Nick. Doug usually leaves me alone, but because this other one here is loving up on me right now, this one's getting jealous, so there's a lot of dog activity here right now. Excuse me, bud, move over. So with the hose clamps, you can cope this out, and then you can use the hose clamps to draw those pieces in really tight. And it makes it so that you can, I mean, it's made out of wood and it's not super strong, but if you lay it out properly and screw everything together, it's actually really strong for mock-up purposes. And when I did that, when I assembled it, I made a layout board. So this is another piece of hardboard, and if you can see my lines on here, this line is the center line of the heim on the spindle end. If you come down here, this line is center line for the rear bushing, and those are exactly 24 inches apart. And they butt up to these 2x4s. So you put the pieces in there, and then you cut your wood and do everything and assemble it. And then to keep the accuracy over to the actual pieces, I'll actually jig up the metal one in here as well. So when I assemble the actual metal lower control arm, because I'm going to build it off of the same platform, it should be extremely accurate. And when I have these pieces cut out, these pieces that I made in Bentech, I'll just transfer them to a DXF file, and I'll send that to the laser cutter. So the pieces that come should be extremely accurate to this. So once I had the lower control arm mounted in place, and now I have my upper link. The spindle has the dimensions that it has. That's a fixed point, like you've heard me talk about before. And then the upper link is its 24 inches, and I've got it solid mounted to the chassis. But I need to dial in the geometry on the lower control arm. And with the tabs that I made for the lower control arm, if you remember, because they mount on about an angle like this, I told you that when I dialed that in, I was just going to rotate them a little bit back and forth. Now, if you hear some weird crunchy noises, that's because there's a dog right behind me going to town on this Nylabone. This guy's only 18 months old, so he's still got some puppy tendencies in him. But what I did is I put my vice grip chains around these tabs. I did that on both sides. And then I took my drive shaft, and what I want to do is, at first I had just guessed where these are. And as I rotate these up and down, it's going to affect the distance of this pivot point from this pivot point to this pivot point. It's going to change the distance between those two, and it's also going to slide this out and in a little bit. They're real small amounts, but you'll see if you're doing something like this. And remember, I'm trying to get this so that the drive shaft length doesn't really change at all. When you get really close to that point, it becomes hypersensitive to if you go one way or the other. So I knew that I would need to rotate those a little bit, cycle the suspension, find out, take a look at how much the drive shaft moves, and then make a little bit of adjustment, move it back and forth, and find that sweet spot where the drive shaft moves the least amount. So what I would do is I would take this angle finder, and I would set it on that tab, and I would pick a position, and then I would set this up on the other tab because I wanted to keep the tabs the same angle. And then I just would take a magnet and just throw it on the spline here and just push it in, and then cycle the suspension. And as I cycle the suspension, if this gets pushed in or out, I'll see that difference on the magnet. So I'll take it all the way to the top, and I'll take a look and see if it moved. Now, it might appear as though it didn't move, but the axle could actually be pushing in. So what you do is you take it to the top, don't touch it, just look at it, see if it's moved, and then take it all the way to full droop, and then take a look at it again. Now, this is pretty much as high as it'll go before the U-joints start to bind, so I know it's not going to go any higher than this. Now, if we take the camera in here, and if you can see, it did move. The drive shaft extended a little bit, but I'm being serious when I say it moved like 1/32 of an inch. Now, I'm showing you the best case scenario because I've already gone through this and I've already dialed it in, but I'm showing you the process that I did. So there's, let's call it a 1/32 gap right now. But now I need to lower it all the way down to full droop. And again, I'm going to take it as far down as it will go before the drive shaft starts to bind in the U-joints. Alright, so that's down all the way. And if we come in here and take a look, that is still 1/32. If I push it in, it's literally 1/32. It might even be a little bit less. Now, it's really misleading me showing you this because in about 2.5 minutes, I just showed you the process of what I did to dial that in. And I have it dialed in. Like, it moves about 1/32 of an inch, a little bit less. And a lot of that is probably going to get eaten up in slop. I should consider that it doesn't move at all. That amount is so little, if I end up swapping over to non-plunging CVs, that'll work. The U-joints, that'll work. So this will be a really good setup. However, you need to bear in mind, I did that for well over a day, probably 2 days. Now, I'm not out here all day, every day, but I spent a lot of time moving those tabs down a little bit. I would cycle it a couple times, see how much it moved. I would move the tab back, I would mark it, and then I would go past the point a little bit. I did that so many times, it's ridiculous, because once I dial that in and once I weld that, it's pretty much gonna be it. So I spent a lot of time dialing that in, but that's the way that I did it, and that's how I dialed it in, and I'm pretty happy with that. So the next piece of the puzzle was to figure out what my full compression was. Full compression is usually determined by when the chassis will hit the ground, not so much when your drive shaft angles will max out. So I went from the bottom of the transaxle to the ground, which the way it's sitting right now, that's 13 inches. And then I know that I am designing this around a 34-inch tire because that's what I designed the front to. So if I had a 34-inch tire on here, then the center of my stub axle to the edge of the tire would be 17 inches. So I went 17 inches plus 13 inches, which gives me 30 inches. So I know that from the ground here, if I set the center of this stub axle up 30 inches in the real world scenario, that would basically be the transaxle sitting right on the ground if it had a 34-inch tire on it. Now that doesn't exactly mean that is going to be your full compression, but you need to be able to go that far because you're probably not going to go that far. You'll set your bump stops so that at full compression, typically you'll want a couple of inches of clearance so that if you do bottom out on hard pavement or something, your transaxle or your chassis or your skid plate or whatever doesn't actually make full contact with the ground. But I want to set it up so that mechanically my suspension can go that far, and then I'll take some of that out with the bump stops. So what I did is I cut a piece of conduit just long enough so that if I crank this up all the way and put this conduit in there, it will be 30 inches off the ground. So now that is my mechanical full compression. I'm 30 inches up. Can't really tell, but theoretically, if there was a 34-inch tire, the bottom of the tire would be even with the bottom of the transaxle or the bottom of the chassis. Now once I have it at full compression here, you have to take it around and you have to make sure that your axles, whatever you're running, whether they be CVs or U-joints, in my case, that they're not bottoming out. You'll see that as it comes around here, the U-joints get close, and that's where it would bottom out, right in here. But there's actually about 1/8 of an inch, maybe a little bit more there. So what I'm going to do now is I'm going to take this out, and I'm going to drop the suspension as far as it will go before those U-joints start to bottom out on each other. And then once I hit that point, I'll bring it back up a little. So I can feel right here, I can feel and see that the U-joints are bottoming out. So what I'm going to do is take it up a little bit. Until I've got about 1/8 inch, which I do, so this will be my full droop. So if you guys can see, maybe you can, maybe you can't, there's about 1/8 inch of a gap where the yoke is coming into contact with the other yoke of the drive shaft there. But either way, that is what is going to determine my full droop. So that would be full droop. So now I know that on the upside I was 30 inches off the ground. So I'm going to take a measurement from the center of the stub axle to the ground. So if I put a tape on here, I'm about, I don't know, let's call that 7.5 inches. And I was at 30 inches. So if I go 30 inches minus 7.5, what is that? 22.5 inches. So right now, as it sits, it's got 22.5 inches of travel. But that's what I call my mechanical travel. It won't have that much when I set it up. I'm sure I'll strap this up a little bit and I'll probably bump this down a little bit. So I'll probably be around 20. I think with the front I had 20, so I'd be real happy if I had the rear at 20 as well. Okay, so now we have our very accurate mock-up of our lower control arm. We have our geometry correct. We have the geometry correct because we dialed in the tabs so that the drive shaft doesn't compress or extend really at all. We now know our full droop and our full compression. Now that we have all of this information, we can start setting up our shock absorbers and figure out the angle and all that stuff. So the first thing I did to prepare for this was I took the shock absorbers. What I'm going to be running on the back of Wratchet here is I'm going to be running a coil carrier on the rear of the control arm. And on the front of the control arm, it's actually going to have a bypass shock absorber. I'm not going to go into the bypass shock absorber in detail right now because we're not really doing anything with that yet. So I bought this as a regular shock absorber, but I'm only going to be using it as a coil carrier. So the first thing I did is I took it had a remote reservoir on it. I took that off because I don't need that. So I just took that off, and right now I've got a little plug in there. I'll get a plug with a Schrader at some point, but I took that off. And then I took the shock absorber apart, and I took out the valving in there. So right now, this doesn't offer barely any valving at all. It's still got oil in there, basically just for lubrication, and it still has the cartridge in there, but all the valve plates have been taken off of it. So the only purpose of this really anymore is just to carry the coil springs. But this is the first piece that we're going to be lining up. We don't really have to worry about lining up the bypass shock because these are both 2.5 inch diameter with 18 inches of stroke. They're both exactly the same. So as long as I figure out how to set up the coil carrier, then I can just duplicate that for the bypass because they're the same. So the coil carrier is going to mount somewhere around here. If you look at the lower control arm, if you look at it straight on, it's got a straight piece going this way, and it's got a straight piece going that way. This is meant for the coil carrier to install somewhere on here, and then the bypass is going to install somewhere on there. And these are both equal distance, everything's the same on them, but this should give me a good area to land the shock absorbers onto and give it some good strength going back. Now I've left this area open because I knew I was going to have some sort of a shock tower back here, and it's going to get pretty crowded because I'm going to have a coil carrier going here, and then I'm going to have a bypass going here, and it doesn't look tight in here right now, but you'll see that where that coil carrier goes, it's actually going to get pretty close to this part. So I need to figure out what my limitations are on the coil carrier with its 18 inches of travel. So the first thing I need to do is I'm going to put the lower arm up into its fully compressed position, and then I'll fully compress the shock absorber, and then I'll put it up there, and that will show me roughly where that needs to connect up here. Alright, now it's in the fully compressed position, and I'm pretty sure these shock absorbers are going to land somewhere around here. So I'm going to take this coil carrier, I'm going to compress it, I'm just going to push it up against here, and I'm just going to see where it ends up, and that'll give me an idea on how to kind of rough build just a plywood, just some sort of structure out of wood to get me an idea of where this needs to go. Alright, now fast forward a little bit. I don't want you guys to think that this happened in an hour or anything. This is another, at least a day, just making this temporary mock-up of a shock tower. You can see again, I'm a huge fan of the hose clamps, and I have this clamped in place with the hose clamps. Although the dimensions of it are pretty accurate, I do think that the actual shock tower I make will be close to those dimensions. And then I have a shock absorber mounting point set up here. This is screwed in place, but when I dialed this in initially, I was just clamping this with the vice grips. I would just, before I had the screws in there, I was just clamping this with vice grips. I had 2 vice grips on there, so that as I would kind of cycle the suspension around, I could slide this in or slide it out and move it up and move it down as I was finding the best location. This is the location that I selected, so let me bolt the shock absorber in there, and then I'll show you what I did down at the bottom as well. So I made a mock-up lower shock bracket, basically just like I did the lower control arm. I drew it up in Bentech, and then I printed out the template, and then I glued the template onto this 1/8 inch masonite, and then I cut it out. This template, the template for the lower control arm, is also in my shared folder, and there will be a link to that in the description of this video. So I've got the shock absorber mocked up in place up here at the top, and I needed to figure out roughly where it's going to come into contact down here, and this will go somewhere around here. So in order to figure that out, what I was doing is I would take it from full compression to full droop, and I would make sure that at full droop the shock absorber was almost 100% fully extended. You still want to have a little bit of extra in there, but remember, even at that, this 22.5 inches of travel, it's not going to do that when it's actually all set up. So I wasn't leaving a lot of extra travel in there, but a little bit just to play it safe. But I did that back and forth, back and forth, back and forth many times, and this is what I came up with. Alright, so that's my mount on the lower location. It basically goes back until this starts to tie in, and when we actually build this control arm, you'll see that I'll have all sorts of extra material built into this part of the control arm, both on this leg and on this leg, because this will be the leg carrying the bypass shock. So a couple of things that I had to pay close attention to. Again, you're missing at least a day's worth of me going up and down and up and down and up and down, just making all sorts of adjustments, but these are the locations that I came up with. But I was trying to get the shock absorber or the coil carrier as close in as I could here, but still have room for clearance of all this. This is the piece that goes between the 2 springs, and I've just got this on here because that reminds me that the springs are going to be as wide as this. So you have to make sure that that has clearance both in here and in here, because you'll see it starts to get pretty close to this bar here. And you've seen me talk about in other videos, good shock absorber location is when you're at full compression, your shock absorber is 90 degrees to the control arm. And you can see that at 90 degrees, or at full compression, that is basically at 90 degrees. It's a little bit under, but it's really good for what I'm looking for. And then as this droops, that angle will get sharper and sharper and sharper, so it'll have less strength. But when it comes up to full compression is when it will be at its strongest. Now you can see at full droop, there's still plenty of clearance around for this piece, and then you also have to keep in mind that there will be a coil carrier down here, but there's plenty of clearance for that, plenty of clearance for the axle, and plenty of clearance for the upper link. And now you can see that it's obviously no longer at a 90 degrees. If it was, that shock absorber would be going out this way, but this is a good setup to have it, because now it will have the least amount of strength at full droop. But as this arm comes up and gets closer to 90, the force that this shock absorber or the coil carrier or the bypass shock will exert on the lower control arm will get stronger as the arm gets closer and closer to full compression. And then I had to be real careful as things came in up here, that as the coil carrier got closer and closer to this bar, there was still going to be room for that spring, which there should be, because if I bring this spring carrier down, there's still room for it to go by, so that I don't think that's going to be a problem. And there's still plenty of room up through here. So in a nutshell, that's it. That's the layout of the shock absorber. I think that's going to work really well. It gives me 22.5 inches of travel. which is more than I need. Like I said, I'm gonna bump strap that in probably to 20, if not a little bit less. So that's it for this video, guys. I got the lower control arm. I mean, theoretically in this video, I really didn't make anything, but I could not glaze over this video and just go from this top link right into making the lower control arm. The next step is going to be to order up the parts for this lower control arm, get them, weld them all up, and then install it. But I couldn't go from making this link right into making the lower control arm because you guys needed to know how much setup there was involved in making sure that all of this stuff works. You saw how I had to play with these tabs to get the geometry correct, and then you saw what I had to do working with this shock tower. Now this shock tower is got a long ways to go, but if you remember, the first temporary mock-up lower control arm I made was nowhere near what this one was going to be either, but that's kind of how my brain has to work. First I have to put something in place that will hold the pieces into position, and then my brain can start looking at that and figuring out exactly how I want to draw this up, how I want it to be, with it being a bushing back here, a heim over there, uniballs up at the spindle end. I have to figure those things out over time. Now that I've got a temporary, a real crude mock-up going of the shock tower, I can also start, my brain will start thinking about how do I want to make that? Do I want to make that out of flat stock? Do I want to make it out of round tube? Are the shock absorber ears going to be permanent? Are they going to be removable? How do I want to do that? So now that I have something up here holding things in place, I can actually start thinking about that. That's what I did with this lower control arm. In the next video is most likely going to be, once I get the pieces on hand, it's going to be me welding up the lower control arm and then actually mounting it in location, making sure that the tabs are where they need to be. I'll get those more solid welded in place, and then I can shift my focus to the shock tower. So, you know, some of the videos are a lot of fabrication, some of the videos are a lot of setup and how I did this and how I did that, and apparently that's what this video was. So, thanks for watching the video. I hope it's helping you guys out with whatever you're working on. Remember, the drawings for this lower control arm and for the shock absorber mounting tabs will be in my shared folder under Wratchet files, and I'll have a link for that in the description. So thanks for watching the video, guys. I hope it's helping you with whatever you're working on, and I hope to see you on the next video.